Hello, welcome to the video about single linked list. Today you are going to learn what is the single linked list, why we need it, how to implement it in Python. But before defining what it is, I want to focus on why we need this data structure. We have the array and it is a data structure that already implemented in programming languages. Why we need linked list instead of using arrays? To understand why, first we need to know what is the array, pros and cons of the array. Let's start with understanding the array. An array can be defined as a series of elements of the same type in contiguous memory. To make the definition clearer, let's check this figure. In the figure, there is a series of elements from data 1 to data 6, and their memory locations are contiguous from 100 to 105 with a fixed distance, and also every element is indexed from starting 0. Like other data structures, array has some strengths and weaknesses. Accessing the elements randomly can be counted as the first strength for array. And the second one is it only needs to store the value of the element, nothing else more. And it is also good side of this array data structure. The third one is as it has sequential memory locations, it is really good at cache locality. When it comes to the mention of the weaknesses of array, the first thing to mention, it has a fixed size. We should give the size of the array while the initialization step explicitly. With this given size, it allocates the memory at the beginning of its creation. For instance, if you create an array with size 10, but you want to only insert one element, the other 9 space is nothing more than a waste. So this array may lead memory waste. Also, insertions and deletions are inefficient. For example, if you want to delete data 1 from this array, you should shift other elements to the left side. So to execute one delete operation in the background, there are 6 different operations to be done. When it comes to defining single linked list, it is a collection of nodes with a specific condition. A node can have a link only to its successor in this collection. If it has no successor, its successor should be defined as null. So, what is different than array? Insert and delete operations are efficient and there is no need to shift. It doesn't require fixed size, it can grow or shrink dynamically. It is not allocating any other memory if there is no data to store, because it has the dynamic size. It is a major output of the second one. But of course, it has some weaknesses. Search time is slower than searching in an array. It needs more memory to store one element. It also stores the location of the next element in the sequence. And sequential access is slower as it doesn't store the elements sequentially in the memory like array is doing. Let's start the implementation of single linked list in Python. First of all, I want to create one Python file. You can give any name, but I want to give single linked list. I want to have explicit naming. To create this single linked list, we need two different classes, one for node, one for single linked list. As node is a prerequisite for single linked list, I need to create the node class. And node class holds two different attributes. In our case, it is a data and next node. And I can create this kind of init function. Set data equals to data and set next node equals to none. In the first step, the next node is empty because we don't know the next node. But to set the next node, we need to have a new function. Yes, we can use setter function of the Python, but I want to keep things explicit to make it more clear. I want to create set next function with next node parameter, and its only thing is set the self next node to the given next node. And also I want to create get next function which only returns the next node value. Also I want to create one another function to get the data. As I said, I want to keep things explicit, and it is just returning set data. And we finished the implementation node class. Okay, right now we can start the implementation of the signal linked list class. And this signal linked list is just holds the head value, and it can be initialized as a non-value, and self heads equals to heads. And we implemented the signal linked list in a basic way. But I want to add a couple of functionality to that. First of all, I want to check if the single linked list is empty or not. I want to define this empty function. It is easy to check if list is empty or not by just checking if it has some values in as a head or not. Self head is none. If self head is none, this signaling this is empty. If it has some values, it is not empty. It's just like that. Just before checking it, I want to also create one another function add to head. I want to add some data points to do at the beginning of this signaling list. And to do this, there is two different things to mention. There is two cases we need to handle. If the signaling list is already empty or if it has some head values. But at first, we need to create node from that data. And then we need to check if the linked list is empty or not. To make things easier, I want to just first implement if we have some data in the head value. If so, we need to do this kind of thing. We need to get the head, previous head, of course, in that case, head, and then we need to add as the next of the new node, and we need to set the new head as node. Let's try what's going on. I want to create one object from single linked list. It should be an empty array. I want to check first. Yes, it's an empty array. If I am going to add new value to the beginning of this array, in that case, let's add 100. Just want to check if it is still empty or not. Yes, it is not empty, but I am not sure if we add 100 or something else. I don't know, it can be something different. To see that, unfortunately, we need to implement one more function, because if we want to print this signaling list, it is just going to give some reference object, and we can't see anything. And to do this, to see what's going on inside this list, I want to create one pretty print function. It will be like that. I want to get the head value at first, and then if there is a head value, I need to check. Just print the data of the head value and assign node as the next node. It's going to stop when the next node is empty. Let's try if it is working. Of course, we need to change this part. Let's print before adding this 100. There is nothing, of course. And then I want to also test this one. If I am going to add a new value at the beginning of this list, I need to see first 102 and then 100. Okay, let's skip the other print functions. Yes. And this add to head function is also working well. I want to implement another function, add to tail. In another word, I want to add some values to the end of this list. To do that, again, I need to create one node from that data. It's a bit different than the previous add to head one, and it is a bit more because I need to find the last value of the list right now, because it is easy to find the head value, the first value, because it is just self head, but I need to go at the end of this list, linked list. Of course, it is not if it has some data. If it is empty, it is easy. Just add as a head. If it is not empty, we need to go to the end of the list. To do that, first I need to, let's say, head, in that case, self head. I'm supposing that the tail value is self head, but it's not. And then if this value is this tail has next values, I just want to go iterate more and more. It's a while loop which will end when tail value has no next value. So at the end, after this while loop, we will find the last value of the list. And then I need to set the node as the next node of the last node. Let's try this one. I want to add another data as 5. Let's try that. I want to delete this part, and then I want to print again. In that case, what I am waiting to print, first 102, second 100, and then 5. Yes, it's also working well. But how about deleting the data from linked list, signal linked list in that case? I want to delete some data from head. If list is empty, I can't delete anything. I don't want to raise an error, but cannot. I just want to print something. Cannot delete from empty list and return false. You can return anything, or you can create an exception in here. It's all okay. If it is not empty, the list, I want to get first the head value, and then I want to get the second node by getting the next node of the head, and then I want to assign the second node as a first node. Of course, I want to delete from the memory the head, the previous head, and that's it. Let's try this one. I want to print again, but before print, I want to delete from heads, and in that case, I am going to delete this 102. Let's check it. Yes, it's also working. Okay, I want to delete from head, not head, tail. Again, it's the same. If it is an empty array, empty list, I can't delete anything. If it is not empty, I need to go to the end of this list. Let's do the same thing what we did here. But I want to make things a little bit different. Like I get the first, and then I want to create while loop, like if continue when there is until there is no next, and continue until there is no second next. So I can reach the second value from the end, from the end of this. The tail is tail get next in that case, and last item actual last item is tail dot get next, and I want to set as null and delete last item. Okay, I want to check it and delete from tail. It will give me 102, 100, and it will delete this 5. Also, I want to add search function if the list has some specific data. Again, we need to check if it is empty, return in case false. Else, I want to get the self-head and then delete until I found this specific data. While head is not none, if head get data equals to data, return true. We don't need to we don't need to continue at the end of this list if we had the data at the beginning of the list. If we didn't return here in this while loop, there is probably no data. There is definitely no data in this list. Okay, without deleting this, I want to search for 5. I want to delete this. Oh, okay, I forgot to add this thing. I need to assign the heads as head get next because I created and loop. Let's check for 3. It's not available in the list. Okay, I want to also get the length of the list. To get the length of the list, we need to create a counter and we need to go from the beginning of the list to the end. Heads again, self heads. While head is not none. Counter equals to 1. It's new value to the counter and then set against heads get next and return the counter. Let's check. This should give 3. If I am going to add 4 new values, it should give 7. Thank you for listening